So looking over, hopefully you guys looked over and read through that first couple of sections of Chapter 1. So looking over those, kind of working through some of the terminology that we're going to be using throughout the semester, kind of getting an idea of what statistics even is kind of where we're aiming for in these first couple of sections. Just a preview, and each section, well, a couple things. First of all, the first section of every chapter is just a quick overview of what we're going to talk about in that chapter. Never has any homework associated with the first section, but anytime we do the first section, the second section's already tied in there with it too. We'll be able to cover both those today, which is where we get into things a little bit deeper. So first of all, just a quick preview of what Chapter 1's even about. The goal of statistics is to learn about a large group by examining data from some of its members. Data. Data is just collections of observations such as measurements, genders, survey responses. If I was to ask how many people drove to school today, the number of you that would raise your hand saying, yep, I drove to school today, would be a piece of data. So anytime we're looking at, if I went through and I just counted how many males, how many females are in the class, again, pieces of data. And so taking that data and trying to collect it and make sense out of it is what we're really looking for in statistics. Statistics then is the science of planning studies and experiments, obtaining the data, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. So statistics is more than just taking the numbers and crunching the numbers. You got to figure out where to even get the data from, how to make sure that you have a good, sound survey that you're using to get that information, and that you haven't already tainted the results just by the way you gathered the data. And so there's a lot of stuff involved in it. And then how, once you've taken this information and made sense out of it, how do you present it to others so they know what you found and what you're doing with it? So there's a lot of pieces involved when you're talking about the statistics. And I want to do this quick video, which is a really good summary of showing some statistics.
Animating the data in real space with a bit of in the West and the rest, is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you just seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
Okay, I like that one. I know it's getting be a few years old since it stops in 2009, but real good example of taking statistics and finding interesting ways to present the information, to compare the information. Like I said when we were looking at this previous one where you're trying to plan the studies and the experiments, so they definitely figured out how to obtain all that data, found a way to organize, summarize, present it, showing you the interpretations, and trying to draw conclusions as far as looking at what we can predict as that future as it continues to go towards that, hopefully, healthier and wealthier nations as we go. So lots of different ways to look at things other than just pulling the numbers. Obviously, we're not going to be nearly as creative as what they were on here, but starting to look at where you're pulling a lot of that information from and how to understand when you hear some of that different stuff is really key things I want you guys to look for. All right, going through some more terminology. A population. Population then is the complete collection of all individuals, scores, people, measurements, and so on to be studied. The collection is complete in the sense that it includes all of the individuals to be studied. So if we were looking at what he was dealing with, then that would mean he needed to look at every single nation to do the entire population. Obviously, just did 200 countries. He had a sample, did not take everything. If we were talking about NCMC as our population, then we would want every single student, and there's about 1,800 students if you include the dual credit for NCMC. And so we would have to know information about every single student if we were wanting to do the entire population. Most of the time, trying to do the entire population is not very, doesn't make much sense to try to do because it's a lot of data and a lot of information to try to pull. Most of the time what we look at instead is just samples. And so when you're looking for that sample, the sample then is a sub-collection of the members selected from that population. So if I'm trying to do the census is collecting information from every single member of that population. The United States does a census every 10 years. And so in every 10 years, we have every single United States citizen fills out the information for that census. And if you don't send it in, they come to your house and they ask you the information. If you live on the street, they try to track you down and find you. They try to make sure that every single person is included when it comes to the census. Obviously, only do that every 10 years because it's extremely expensive, extremely time-consuming, and all that kind of stuff. And they look for, when they do the census, one of the things they ask for is like the age of every single person in your household as of, I think it's April 1st of that year. And so they have a very specific time that they have as that is the census date to be able to look at, for instance, ages of United States citizens. And so that census then is taking information from every single member compared to the sample, which is just your sub-collection, just getting some of the smaller groups when you're doing things. Again, if we're talking about NCMC students, we might be taking that census to be, it could be age of NCMC students, which is one of those things you report when you're enrolling into things. So I could go over to the registrar and I could have them pull data for every single NCMC student. But if I was not, and we'd have to be careful of how we're getting that data to make sure it's not attached to anybody's names for security purposes, but I could get that information from them. More than likely, I would end up looking for a sample and just getting a smaller collection of that data. Now, we could do population being just statistics students, and we're looking at the population of statistics students, and so finding the information for statistics students this semester be easier just to deal with the entire population than to try to find a sample of that. So looking at that kind of makes a difference of what kind of information you're trying to pull and how big that population is that you're dealing with. All right, so some key concepts from this chapter that we're going to be looking for then. Sample data has to be collected in an appropriate way, such as through a process of random selection. If sample data are not collected in an appropriate way, the data may be so completely useless that no amount of statistical torturing can salvage them. If you go through and, let's say I'm trying to figure out the proportion of males and females on NCMC's campus. And to figure out my information, I go over to the girls' dorm and I collect information on how many girls and how many boys are that I see, or for my sample, is people that I come across to there. Well, I have just distorted the data, extremely biased, because I'm now in the girls' dorm, and so the likelihood of having guys come through is lower, not impossible, but lower than had I been somewhere that's a little bit easier to look at doing. So how we collect our data, extremely important. We don't spend a ton of time this semester really looking at going through and we won't be collecting a lot of data and all that kind of stuff, but definitely one thing we will always want to pay attention to is how was the data collected? Was it a good random sample where everybody has a chance of being in my sample, or have I already biased the sample just by the way I got my information? When you read statistics, and statistics are everywhere, when you read statistics, and especially if you're in a business that starts using some statistical data to make decisions, you've got to make sure that you're checking that statistics, that it is good statistics, that it's got a good, firm foundation of where they even pulled the information from, because it should be included in there of where you're getting that stuff from, making sure that they haven't messed things up just by any of their procedures that they've done, and making things biased just from the beginning. Because if you've already started with biased information, it doesn't matter what we do, you can't get good out of it. Questions so far of just that generalization? All right, then let's look at doing some statistical thinking. Key concept for this section then, it doesn't, whether we're conducting statistical analysis of data that we have collected or analyzing a statistical analysis done by someone else, we should not rely on blind acceptance of mathematical calculation. We should consider the following factors. In other words, think critically about what you're looking at. We need to think about the context of the data, the source of the data, the sampling method used, the collections, and then the conclusions, and then the practical implications. So making sure that we have a good, legitimate survey, and we're going to go through each one of these as we do things, but making sure that our information is legitimate to begin with, that it's got a methodology we can go back and verify things later is extremely important. So going through each one of those. First of all, when we're talking about the context, what do the values represent? Where did that data come from? Why are they even being collected? An understanding of the context will directly affect the statistical procedure that's being used. So going through and choosing those correct methods, making sure we have good formulas that trying to look at what I've got here. That we're making sure that we've got a good foundation of what we're looking at. For example, if I looked at this, I think this is probably a good example of showing you guys what we're talking about with context. Given the above data, can you determine what those values represent or where they came from? Okay, knowing the context of the data, extremely important. This could easily be, the age of a vehicle and the number of miles the vehicle's gone. Well, if this is looking at age and mileage of the vehicles, and then we would be looking at having paired data, and we could compare how old the vehicle is compared to how many miles it's driven, and use that to kind of do some information. Finding the mean or the average of the number of miles would make a lot of sense then. On the other hand, if this was your student ID numbers without the 000 in front of it, and it was your age, huge difference. Because now the student ID numbers is just helping me represent different people, and I can't average people. Finding the mean student ID number doesn't make any sense. It's just a way to verify which person which individual we're talking about. So knowing where that information comes from, extremely important. If we're doing this as student ID numbers and your age, then paired data doesn't make any sense. It's just helping me look at saying this is the different ages of these different individuals. So understanding where that data comes from, extremely important. So when you look at data, looking for that is going to be a key thing to pay attention to. The source of the data is important. Is the source objective or is the source biased? One of the examples that this book uses a lot is talking about drug companies and looking at creating new drugs and seeing whether they're effective or not effective. Well, depending on who is doing the research on whether it's a good drug or a good new medicine, or if it's a not so healthy medicine, if you're looking at the drug company that has just spent the last 10 years trying to develop this new medication and they've spent millions of dollars into the development of it, having them be the ones that run the test to say, yeah, this medicine's working great, might be a biased sample. Now, not saying that just because a drug company has put millions of dollars into it that they're automatically a biased sample, but before the FDA approves it, they're going to make sure they have a second person or second company doing this research to make sure that they really verify what's being done. That you have somebody that's objective, that doesn't have money in the game trying to make things happen. So knowing where that source of the data comes from, important. You want to make sure, is there some incentive to distort or spin the results to support some self-serving position? I know that's been a few years back, but when it was coming to the research on global warming, huge problem came about when they realized that the scientists who are getting paid to do research on global warming, and knowing that if they couldn't show global warming were going to lose their jobs, distorted the data and tried to show that there was more global warming than what was actually happening. And so that alone, just through all of that research and all of the conclusions that were being drawn, got thrown out the window because the original data was distorted. And so they had incentive to distort that data because they wanted to keep their own jobs. Is there something to gain or lose by distorting those results? Be vigilant and skeptical of studies from sources that may be biased. It doesn't mean you automatically throw it out that just because that company wants to show that more people use their product than another product, that they're saying, yeah, 2/3 of the people use, I know when I was a kid it was Crest toothpaste, that 4 out of 5 doctors recommend Crest toothpaste. So if Crest is the one doing the research, good chance that they had a biased sample, that they may have surveyed the doctors that were accepting their free samples and asking them, so do you recommend Crest toothpaste? And of course, if they're handing out their free samples, they're probably going to say yes. And so that alone distorted that data. But it could very well be that just because it's a sample coming, or the people creating it is self-serving, they might not distort the data. Hopefully we can say most people are going to be honest and aren't going to distort it. But you've got to think about that as you're looking at stuff. Just because there's numbers involved, don't just assume that everything that has created that has to be viable and reliable and trustworthy. You really have to make sure that you stop and think through what's going on things. Oh, I had another example that I wanted to mention on here when it came through the source of the data. One of the articles that I'd run across was that media bias distorts the details of past earthquakes. That trying to look back at research, trying to see, how have earthquakes been increasing in intensity, or is it kind of staying the same, that type of thing. Well, trying to look back at how severe an earthquake was before we had the data collections. One of the key things they used to look at would be how it was reported, because you've got the newspaper articles and all that kind of stuff. Well, trying to decide how intense an earthquake is, part of it's based upon how much damage is done and how far away it's felt and all that kind of thing. Well, if you think about the newspaper articles, newspapers sensationalize things. And so when it comes to seeing how much damage was done by this earthquake and using media as your source to determine how strong was that earthquake, you've distorted the data just by the way they're trying to be able to go back in time and look at what happened. And so that's one of those things, again, just to kind of be aware of, could be a issue that you have to pay attention to. Questions so far? All right, another thing to look at then is the sampling method. Does the method chosen greatly influence the validity of the conclusions? So how did we get this information? Voluntary responses or self-selected samples often have bias. Those with special interests are more likely to participate. These samples' results are not necessarily valid. Other methods are much more likely to produce good results. Voluntary responses would be things like if you're watching the news and sometimes you'll see that they have, if there's an opinion poll, and call in and they'll give you the phone number or text this number with your opinion on things, and then a little later in the news report they'll report in that 55% of people support blah 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 blah. Well, it's 55% of the people that answered their call, and most of the people that whenever you are just saying, okay, call us if you have an opinion, have strong opinions. They're either strongly for it or they're strongly against it. Those people that are like, yeah, it could go either way, don't really spend the time calling in. And so when you're looking at those voluntary responses, you have to realize that it's 55% of the people that responded strongly support blah, 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 blah. You've got to be aware of what kind of method was used to pick it. When we get closer to the end of the semester, NCMC asks for a voluntary response whenever we ask you guys to do your, what do we call them, course evaluations. I think was what we call those, where we ask you guys to go through and basically grade all your teachers. Very much a voluntary response because we cannot force you guys to sit down and do it, and we definitely don't get everybody to do things. Please do it when it comes to the end of the semester. It makes our results a lot more valid if we actually had a higher percent of people that did it. And it's one of those things that even though we know it's a voluntary response, our administration still looks at it and still recognizes what's being said. And we have those extremes. Those people that really liked their teachers are likely to go ahead and spend the time to say, yeah, this is a good teacher, keep her. Those people that think this teacher stinks are more likely to say, okay, this was the worst teacher I ever had, get rid of her. Those people in the middle are like, yeah, she's just as good as every other math teacher I've had, not that much better, not that much worse. They're not the ones that spend as much time answering those. And so we get those extremes. And recognizing that when you're looking at something that's a voluntary response, that we've lost a lot of the validity to be able to put a lot of trust in that data. But again, if I could get 100% of the people actually answering that, then we could actually say we could trust that data because it's got a good response on that one. Questions about what we're talking about with sampling methods? Another sampling method, and I don't think I brought an example of it with me this time, is frequently in the mail, you'll get these questionnaires, these surveys. And one of the things, and it kind of hits sampling methods, and it kind of also hits, which one is it that it's going to hit? Well, I guess it's kind of hitting both the sampling method and the source and the context of the data. Is if you get these mail-in surveys, and a lot of times it's they'll ask you questions like, what type of soaps do you use, and what type of shampoo do you use, and they'll have a list of, do you use, and they'll list about 5 or 6 shampoos, and then they'll have other. Well, when they have those listed, first of all, they're kind of leading you in that direction just because they're giving you the names that they want you to say. But a lot of times you're also aware of the fact, and they've got it written on there, that they'll send you coupons a lot of times for things that you answer that you use. So some people will just check 3 or 4 things of, yeah, I use all 3 of these shampoos. That way they can get the coupons and be able to I guess, actually end up using those or giving the coupons away or whatever. But having some sort of incentive to answer a certain way, just knowing that you've got this coupon tied to it, is another thing to pay attention to as you're looking at those. All right, conclusions. Again, when you're looking at the data, things that you have to pay attention to is what kind of conclusions they draw from them. When you draw conclusions from your data, you need to make the statements that are clear to those without an understanding of statistics and its terminology. This will become important as we get towards the end of the semester, and we're trying to look at whether or not there is a correlation, a relationship between different things. And depending on how your sample was created, whether it was more of an experiment where you designed a certain thing, or whether you're just taking information that was already given and already done without trying to alter it, determines what kind of conclusions you can come to. And we'll start off with a very statistical, at first it's going to sound like statistical mumbo jumbo that nobody knows what you're talking about. And then we have to turn it into, okay, what would an average person understand? And trying to make sure that when you present it, that it's not confusing is going to be an important thing to be able to pay attention to and do. You also have to avoid making statements that are not justified by the statistical analysis. One of the key things, again, if I'm looking for a relationship between two things, I might see that there's a relationship between the height of my students and how well they've been doing in my classes. And I might see that it has tended to be for the last 2 semesters, I'm making stuff up right now, but I might notice that for the last 2 semesters, my taller students have been doing much better than my shorter students. And just because I see that there's been this correlation, this relationship between two things, that doesn't mean it's a cause and effect relationship that I can say just because you're tall causes you to do better in statistics. That's taking information and then twisting it into stuff that's not justified. That is something that happens a lot in the media. A lot of times when you're talking about reporters, they don't have a really strong statistical background, and they're going to see this relationship, and they want to sensationalize it because they want you to read their articles and really pay attention to what they're saying. And so they'll take this a little bit, and then they'll just sort of twist it just a little bit so that it sounds a little better. And in that little twist, with not having a good statistics background, they've changed the information. They've changed what they're saying, and it no longer really is the same as what was concluded by somebody as they were doing that original survey. Also, we have to be careful about the practical implications. State practical implications of your results. There may exist some statistical significance, yet there may be no practical significance. Again, if I had noticed that there has been the statistical relationship between height and grade, and it may be that, it's just this little small increase, that there's just been a little bit more chance that people that are tall do better than those people that are shorter, it doesn't create a practical implication that I can really start saying that, well, to make people better in statistics, we need to stretch them and make them grow better. Because there is no practical implication to that. So looking for those and just keeping common sense as you're looking at stuff is extremely important, because sometimes people get bogged down in looking at all the data and all the information, and the common sense kind of gets lost in that process. So common sense might suggest that the finding does not make enough of a difference to justify its use or to be practical. Again, that's another thing that happens a lot in the medical field. There might be some sort of correlation, some sort of relationship between different things, but is it going to really have that significant of an increase? If it is the fact that they find a relationship between, I'm trying to think of something extreme. If somebody eats 5 apples a day, that they increase their lifespan by 6 days. Well, getting people and telling them, well, you really need to eat 5 apples a day for the rest of your life so that you can live longer. There may be some sort of correlation between that by eating more of the fruit, it has increased their lifespan. But really, is eating 5 apples a day increasing your lifespan by 6 days on average strong enough increase to really make it worthwhile of eating 5 apples every single day? Not really. And so that's where, even though there may be a statistical significance, that there really isn't any kind of practical significance as you're looking at those. Questions there? All right, I'm going to go ahead and give you guys your homework. I want to go ahead and start section 3. I had a feeling I might end up getting a little bit further, but let me go ahead and give you this part. I'm not going to give you any assignments on section 3. So this will be your guys' homework for tonight. If you haven't read sections 2 through 9, read those. Hopefully you already have. And then always when you're reading things, do read those original chapter problems because it kind of builds on those as you read through the rest of the chapter. The homework then's on pages 9 through 11. Next time we'll be doing sections 1.3 and 1.4. So reading ahead is wise in here. That way, again, it's not all new stuff as I'm going through things. Homework, when you're turning that in the top right corner, I do like to have your name, the class, which is, in this case, the Math 125. And then the textbook section or page number. So either writing that it's page 9 or writing that it's section 1.2 would be great. I guess one other thing I wanted to mention too, when it's coming to homework, if you guys want to take pictures of the assignments, then by all means take pictures because it makes sense. I've seen people doing that quite a bit. That way you don't have to worry about did you write it down right. I am recording classes on Tegrity, so if you don't get it written down or you miss a class, if you miss a class, watch the whole class back later. But usually it's the last slide on Tegrity. This time it won't be, but usually it's that last slide on Tegrity, so you can go back and look at those later to be able to get the assignments. But I do want to go ahead and start section 3. Just got that. Okay. When we're looking at section 3 is going to look at the different types of data. So the key concept in this one is the subject of statistics is largely about using sample data to make inferences or generalizations about an entire population. It is essential to know and understand the following definitions. So keeping in mind that difference between the population and a sample. Population is every single member of that group. Sample is just a smaller sub-collection of it. So statistics class would be a sample of the entire population of NCMC students. Not a good random sample, but it is a sample of all NCMC students. We could be talking about NCMC is the students in NCMC would be a sample of the population of all college students. So your different populations would talk about if you did college students, it'd be every single college students, let's go in the United States. Or we could do the population being just NCMC students, or we could do the population as being the entire United States. So depending upon what that population is, we can talk about those sub-collections being your samples of those. And whether we're working with the entire population or whether we're working with the sample of that population changes how we calculate our statistics, changes the kind of conclusions that we can draw once we find some information about those. All right, so if we are finding a numerical measurement describing some characteristic of the entire population, we call that a parameter. So if I was talking about NCMC as being my population, and I went over to the registrar and I said, I would like the ages of every single student, and I took the ages of every single student and I found the mean, which is the same as the average of the ages. That would be a parameter. That is a description of all of our students on campus. Versus when you're taking a numerical measurement that's describing the entire population, we're talking about finding a parameter. On the other hand, if I just took a sample of NCMC students, so I went out and I asked the registrar to give me, and I just randomly found a way to select 30 NCMC students instead, and I found the ages of those 30 NCMC students, and I found the average age of those 30, the mean age of those 30 students, then that would be a statistic. Because the statistic is only taking that numerical measurement and describing what you have from the sample. Now, hopefully, if my methods of collecting my data were valid, then hopefully my statistic of what the average age of my 30 sample students are should be pretty reflective of the average age of all NCMC students. But, again, I can bias that data depending on what I do. One bias is that if I just went out and randomly picked the first 30 students that I saw, then that alone has already biased it, because I'm probably not going to see any of our dual credit students. And when we talk about NCMC students, we are including, when I say the 1,800 students, I'm including our dual credit. And so they're not going to probably walk by me if I just did a nice convenient sample of just asking the first 30 people that walked by me, how old are you, and then just wrote it down. So I've already biased my data just by my sampling techniques. So that's the reason why you have to be careful on how we collect that data, that you may have an unknown bias when you're doing things. We've talked about that difference between quantitative and qualitative data. Quantitative data has a number associated with it. If I'm asking for their age, that's a number. If I'm collecting heights of people, that's a number. So when you have a number associated with it, we have that quantitative number. That could be a count also. I could just count how many students are female. And so then that would be still a numerical number that I have associated with that. When we talk about categorical or qualitative or attribute data, this is when you have names or labels. So they're representing different categories. So if I was looking for, from the 30 students I collect, I write down their shirt colors. Well, shirt colors are going to be a category. You can't average shirt colors. You can't take that and turn those into some sort of number. And so when you're looking at doing that, you're looking at a categorical data. If I was talking about the number of the types of vehicles on campus, I could go through and look at the number of, we could go with Chevys and Fords and Hondas and do it that way. We could be looking at the different colors. We could describe the vehicles, lots of different ways we could describe them, but most of the ways we'd be describing the different vehicles are going to be categorical data. So whether it is a quantitative or whether it's a qualitative data makes a difference on what we can do with it. Because if we're talking about categories, you can't take and do any kind of numerical analysis and find, the mean of a category. Doesn't make any sense. When we're working with quantitative data, so we're going back to looking at it as a number, we have two different types of numbers. We have discrete data and we have continuous data. Discrete data is when we're counting things and it's going to jump. And it doesn't always have to be a count, but frequently is what it is. But you're jumping from the number 1 to the number 2 to the number 3, and you can't have a piece of it. If I was talking about the number of statistics students I had every semester, and I went back through the last, let's see, I think this is my 8th semester of teaching statistics. So if I went back through the 8 semesters of having statistics and I took how many students were in each group, that's going to be discrete. That I can't have a piece of a student. There's not a semester that I had 12 and a half students. I either had 12 students or I had 13 students. I couldn't have a fraction of a student. And so that's a type of discrete data. So discrete data is when we're looking at things that are countable, that you cannot have parts or pieces of them. Now, it could be that I might be counting, I'm not sure what to count that would count in halves. Nothing's really, if we were talking about maybe, well, that's not a good one either. If you had something that it might be that you could have a half of it, and you might have 1.5, but you're really not going to be looking at having 1.264 pieces of that. It's either going to be one of them or 1.5 of them or 2 of them. If you had something that you're looking at where it could count by halves, it can still be discrete when you're jumping and only counting by halves. But most of the time when we're talking about discrete, you're looking at it just being counting numbers. You either have 0 of them, 1 of them, 2 of them, 3 of them is usually the numbers we count by. When we're talking about something being continuous, that means it can have any fraction or decimal in between. If I was looking at, the number of cars in the parking lot, we were looking at having discrete data. If, on the other hand, I was looking at the amount of gasoline in my car, the amount of gasoline in my car is continuous data. That as I measured the amount of fluid in my car, that I don't just have 1 gallon or 2 gallons, I can have 1.23 gallons of gas in my car. And so that is something that is continuous, that there's not just jumping from one value to the next value. Even though when you're putting gas into your car that you're, they go by, I think it's just tenths of a gallon that they count by as they're doing it. That doesn't mean that just because it says it's 1.9 tenths of, or, well, yeah, let's go with 1.9 tenths of a gallon, 1 9 tenths of a gallon that went in, that it had to be exactly 1.9. You might have gotten 1.93, or you might have gotten 1.84 or 8.86. That it still has that continuous amount that you could have any fraction or decimal, just depends on how accurately you're measuring it. But it still is that continuous data. So it results from infinitely many possible values that correspond to some continuous scale that covers a range of values without gaps, without interruptions, without jumps. So all those fractions and decimals are possible. I think that is where I'm going to stop for today. I think that's where we're going to stop for today. So do that homework from that from section 2, and I will see you guys on Friday.